Alright guys, I'm back. Had my knee surgery, recovering, took last week off just to focus on my master's and just kind of getting better. So thank you for sticking with me, and we will start resuming. And we're going to resume with one of the hardest things. It's going to be two things. The first is the fundamental theorem of algebra, and the second is the rational root theorem. Now at every level there's a fundamental theorem in mathematics. The fundamental theorem of algebra simply states that any polynomial of degree n has n roots. So to go through a few functions that we've used, you have a linear function that has a degree of 1 because of this guy right here, and that has one root. A quadratic is squared, so therefore it has two roots. A cubic is cubed, so you have three roots, etc. Now what the rational root theorem allows us to do is that if I had a function, right here I have x plus 1 times x minus 2 times x plus 4. If I went through and distributed, I would get this polynomial. Now I know that it has the roots of -1, 2, and -4 because in this factored form, if I set each of these equal to 0, I would know that. And over here is an example of when we throw in complex numbers, we would have x plus 3, x plus I, and x minus I. Go ahead and distribute these out. I get I times I is I squared. Remember, I squared is -1, so minus I squared is a positive 1. Distribute out, I get this cubic polynomial, and the roots are -3, I, and -I. Again, I would get those by setting these equal to 0. But what if I was only given this polynomial here? I probably couldn't work backwards to find this factored form. So what we're going to have is something called the rational root theorem, which allows us to find at least one of the rational roots. In this case, -3 is the rational root that we would have found, and then we'd use that to find the other two. Over here, we could have found -1 or 2 or -4. We would have used that to find the other factored forms. Now the process we'll follow will get us a rational root. Once we know a root, we can divide the polynomial to reduce it by 1 degree. We keep doing the process until we get a quadratic, and at that point, we can factor or use the quadratic formula. So given this cubic, I know that it has 3 roots. I know that it has 3 rational and has 0 imaginary. And if it were to have 1 rational, it's going to have 2 imaginary. I can't just have 1 imaginary, because imaginary are always plus or minus. My son is now joining us.
I found you, Dad.
Yes, you did, buddy. Now, what if I gave you this cubic polynomial? First of all, how many roots does it have? Well, since it's a cubic, I know it has 3 roots. So the first thing we're going to do is find the potential roots first. To do that, we're going to take the factors of the constant and divide it by the factors of the leading coefficient. Now this one's going to be easy because the leading coefficient is 1, so therefore I can either have 1 times 1 or -1 times -1. That's why I have the positive and the negative. The factors of the constant would be 6 and 1 or 3 and 2. So what I did here is I started matching up 1 over 1, 1 over -1, -1 over 1, -1 over -1, 6 over 1, 6 over -1, etc. Now I went through and here I have a 1, here I have -1. Now over here I'm going to have another -1, so I did a check mark because this is the same thing as that. See, it's just like in class, an obnoxious child wanting me to stop talking math.
Popcorn?
And so once I have all my roots, I have 8 possible roots, and those are the possible roots that could be real. The others that exist could also be real, or they could be imaginary. Now, what I'd like you to do for now is, first of all, Averson, we're not doing popcorn for breakfast, is to identify just the possible roots. So I gave you a cubic, a quartic, and a quintic. And I want you to figure out what are some possible roots, and you're going to use this ratio right here. So take the factors of the constant. So in this case, this is going to be 2 and 2, 4 and 1, And then also throw in the negatives. So you would have positive 2, negative 2, positive 1, negative 1, positive 4, negative 4, etc. And divide it by the factors of the leading coefficient, which in this case would be plus or minus 1. It's going to progress with difficulty. This here, you'd have the factors of 6, but now you're dividing it by something other than 2. And then this one as well. So try these out, just create the possible roots, and then tomorrow what we'll do is we'll actually use those possible roots to start to reduce our polynomial and find the other roots. Good luck.